Good morning, students. Today we are going to discuss few important topics from the chapter 3, current electricity. Now these topics are very important, and every alternate year this question used to come in your board exam. So the topic is nothing but is your continuation of your previous discussion, potentiometer. Now in today's class we are going to discuss the uses of potentiometer. So the first use which we are going to discuss is your comparison of EMF of two cells. Now this topic is in your practical syllabus also, so you have to do this experiment and have to verify the expression in your practical class. Now you see regarding the principle of potentiometer, it says that under constant current, potential difference is directly proportional to the length. Now that part we are going to use in this experiment. Now regarding the circuit diagram, you see you do have a source, and the source is connected to an ammeter, and after that it is connected to a rheostat. In lab, basically the source which you are going to use is your battery eliminator, and what we'll do, we'll adjust the rheostat and we'll send a constant current that indicates on the ammeter. Now under that constant current we are going to perform this experiment. Now you do have a key K. Definitely you have to close the key K so that there is a current in the potentiometer wire. Now AB is your potentiometer wire. We are trying to show it here. Now you do have two cells. One is your EMF E1, another one is your EMF E2, and positive terminal is connected to the point A, both the cell positive terminal, and the negative terminal is connected to number 1 and number 2. Now you do have a resistance R, and the free end of that resistance R we have defined as your S, and from resistance R you can use the resistance box in place of capital R. One terminal is connected to the galvanometer. Now what we'll do in this experiment, we'll connect S with 1, keeping 2 terminal free so that there is a gap between S and 2. So in this way what we'll do, basically we'll connect the cell E1 and we are not going to connect E2. So at a time we are going to connect a single cell, either E1 or E2. So first of all what we'll do, we'll connect S with 1, number 1. So it means the cell of EMF E1 is connected in the circuit, and what we'll do, we'll try to move the wire or the jockey over the length of the potentiometer wire. Now let me consider we are going to get the null deflection at the point J. So the length of the wire is your L1 from A to J. So under that condition we are going to use that principle of potentiometer, that is terminal potential difference or potential difference is directly proportional to the length. So if V suffix Aj is the potential difference for the length of the wire L1, thenVaj equal to K L1. Okay. Now secondly what we will do, we will disconnect S with 1 and connect S with 2, and again we will repeat the same thing and we will try to find out the null point. Let me consider the null point is at J dash for the cell of EMF E2. So the length is your L2, so potential difference between A and J dash, so Vaj dash equal to K L2. So under that condition we are going to define the experiment. So let me read out here. So why you are getting the null point at J when EMF E1 is connected? Basically the reason is that at that stage the EMF E1 balances the terminal potential difference across A and J, and we are getting null point at J dash when we connect S with 2. Under that condition what happened, basically the terminal potential difference between A and J dash is equal to the EMF E2. So let me brief it out here. Step 1, no deflection at J when S is connected to 1 indicates that Vaj equal to E1. So this is balances each other, that's why no deflection occurs in the galvanometer. Till the balancing condition comes, you are going to get the deflection in the galvanometer, but when it balances, there is no deflection in the galvanometer. So you can say that terminal potential difference or potential difference across the length of the wire balances the EMF E1 of the cell. So VAJ equal to E1. So but from the principle of potentiometer, VAJ equal to KL1. L1 is the length of the wire from A to J. So if you equate E1 equal to KL1, so we are going to get the equation number 2. And this is very important, we are going to use it later on. Now step 2, what we'll do, we'll no deflection at Z dash when S is connected to 2 indicates that VAZ dash equal to E2. So under this condition, what happens? The potential difference balances the EMF. Potential difference is nothing but the difference of the potential across the length of the wire, not regarding the cell. So this VAJ and VAJ dash is nothing but the potential difference across the length of the wire. So VAJ dash equal to E2, but VAJ dash equal to KL2 from the principle of potentiometer. So you can say E2 equal to KL2. So if you take the ratio E1 by E2, you will get KL1 by KL2. So ultimately you are going to get L1 by L2. So knowing the values of L1 and L2, we can define or we can find E1 by E2. So you can find the ratio of the EMF of the two cell, or you can compare the EMF of the two cell if you know the length L1 and L2. So this is very simple and it's very important because every alternate year it is used to come, and in some cases in consecutive year also it is used to come. Now you see the next topic is your determination of internal resistance of a cell. So you have to define the internal resistance of a cell. Now you see the circuit diagram, there is a common part and there is an uncommon part. So you have to remember the common part of the two circuit as well as uncommon part, then it is very easy to memorize. So you see the upper part is common, only the lower portion is different. So in lower portion we have connected a cell whose internal resistance we have to define, that is your E, and across that we are connected a resistance capital R with the key K2. So previously you do have only one key K1, and here you do have K1 and K2, two keys. And what we'll do here, we are going to keeping open key K2 and closing key K1. So let me read out what we have written here. Keeping K1 closed and K2 open, the galvanometer shows null deflection at J. Okay, so under that condition previously, that happens basically the potential difference across the wire VAJ is nothing but the EMF of the cell E. So VAJ equal to KL1, so E equal to KL1. So you are getting one expression number 1. Now secondly, what we have to do, you have to close both the key K1 and K2, and keeping K1 and K2 both closed with proper value of R. K1 and K2 both closed, okay, with proper value of R, the galvanometer shows null deflection at J dash. So here what we have to do, we have to keep K1 and K2 both closed, and we have to take out a specific resistance capital R from the resistance box which we have connected across the cell E with the key K2. So again null point we are getting that is at Z dash. So under this condition it is no longer EMF of the cell because we have closed key K2, so some energy is drawn from the cell, so it is no longer EMF, rather it is your potential difference. So here it is your VAJ dash is nothing but is your V is your terminal potential difference of the cell, and VAJ dash is nothing but is your KL2 as from the principle of potentiometer. So V equal to KL2 if you substitute it here. So terminal potential difference of the cell is nothing but is your KL2. So now what you have to do, you have to take the ratio, that is your E by V. So E by V is your KL1 by KL2. So you are getting L1 by L2. So here L1 is has a higher value than L2. Now the internal resistance of the cell, this topic already we have defined, and the expression which you are getting, which you have got basically, is your R equal to, small r equal to E by V minus 1 capital R. Capital R is nothing but the resistance which you have connected across the cell, and to get the null point we have pick up some resistance value from the resistance box, and that value is nothing but is your capital R. So E by V minus 1 within bracket capital R. So E by V we are getting L1 by L2. So small r equal to L1 by L2 minus 1 within the bracket capital R. So here knowing the values of L1, L2 and R, the internal resistance of the cell can be determined. So this two topic is very important, and you will get this two experiment in your practical class. Now here you have to memorize the common and uncommon parts of the circuit diagram, and definitely we are going to show here in the circuit diagram single length AB of the potentiometer, but actually this is not a single wire. I think 10 wires are there in the potentiometer. So you can assume that A is your one end and B is your another end of the potentiometer wire. So this is all about your these two topic. Please check it out and find out your doubts. Thank you.